Welcome to the worst slides of the night, as you can see. My name is Vasyl Boroviak. Why are you laughing? That's my name. I feel bad when you laugh on my name. People, I hate people now. FlashFX is the company I work in. We are basically sending your money overseas, but using blockchain underneath. It's called Ripple. And we actually can convert your Aussie dollars to cryptocurrency. And currently I am writing GraphQL API so that you can do it programmatically. And we are the only licensed company in Australia who can do that. This is how awesome we are. CPWA is the meetup I co-organize. It should be this month, next month. I don't know when the next is, because we haven't scheduled it. If you want to talk about progressive web technologies, it's not about PWS only, just any progressive stuff like WebAssembly, you know. Come over to me and speak on our meetup. Thank you. So, meet Gordon. Gordon is a British guy. I said British, somebody laughed, you know? All right. He actually, that's his Twitter handle called Espruino. He actually the guy behind the Espruino, the microcontrollers running JavaScript. Oh, I think I made his Twitter handle too small. Let me enlarge it. I think you can see it now. It's all over his face. He's a hacker, as you can see from him. He's a hacker, as you can see from his cat face. Sorry, kitten face. But, you know, doing microcontrollers convert you from kitten to gradually to a macho lumberjack. Why are you laughing? It's not funny. Lumberjacks are cool. All right. So he is the first guy in this world who actually realized he's like Ryan Dahl. Raise your hand if you know who Ryan Dahl is. 1, 2, 3, 4, 5, 6, 7, 8. 8 people. All right. So Ryan Dahl is 9 people. Ryan Dahl is the person who actually first realized that you need only one thread to do hundreds of HTTP requests. Handle 100 of HTTP requests. Yeah, he invented Node.js. So that guy, that lumberjack guy, he also realized the same thing, but for microcontrollers. You don't need something running all the time on your microcontroller. Your device can sleep majority of the time because there is an event loop, and the device will wake up when it needs to do something. So thanks to this, his bright mind, we now have microcontrollers who drain very few battery. And this is the main feature of Espruino microcontrollers. Moving on. Gordon is actually behind this all Espruino hardware, software, website, Kickstarter campaigns, docs, software. He's like doing it all, presenting on conferences. He's like, as you can see, lumberjack of all trades. And this is, he gave me this web graphic of what was the usage of the web IDE, or just IDE, or the website, I don't remember, forum. What I want to show here, this is his third Kickstarter campaign. He launched Puck.js. Puck.js, that's Puck.js. I thought it's a library in the beginning, but then, yeah, no, it's a hardware device. That's when I met him, not him. When I saw a tweet in Twitter, as you might guess. This was his first Kickstarter campaign. I think somewhere around here was his second, and that was his third. And that spike is when he released this device. So also Espruino based. There's one little battery here, but it has a screen. Yeah, and that's the list of devices he invented. 3 successful Kickstarter campaigns, all on time. I don't know any other person in this world who could do this actually. So on the bottom you can see his first device, and then second device is a mini computer running JavaScript. You plug it into your laptop. And the third one is Pug.js up there. I'll tell you about it. Everything. And you can see how Gordon happy because, well, 3 Kickstarter campaigns all successful on time. Now let's get down to hardware part. This slide will be there for a long time. So the closest thing to Espruino is Arduino. Arduino started in 2003 by some students in Italy. I don't know what Italy is. But in 2008, they created a company, those students. And now Arduino is a successful company creating microcontrollers which you can easily-ish program on the language called C++. So, what in Espruino you program using JavaScript. You actually can use some C and assembler, but JavaScript is the king here. I'll show you why. Literally, you can actually connect all those Arduino devices to Espruino because they're kind of compatible. And the difference of these two with Raspberry Pi is that Raspberry Pi is the full-fledged, complex computer running Linux kernel drivers like keyboards, video processing, all that stuff. So on that little battery in the beginning, this little battery, Arduino can run for 4 hours, Espruino for 4 years, and Arduino for 6 months, roughly. It's not like idling. I mean idling, doing nothing. So in the first talk, you know that on the first talk, I don't remember the author name. He said that computers are good at doing nothing. So you can do nothing on Raspberry Pi for 4 hours. On this battery, and 4 years in Espruino. A significant difference between Arduino and Espruino. So in Arduino, you write a C++ code. Raise your hand if you know C++. Whoa! More than 10 people. Wow. I'm so very surprised on the JavaScript meetup. Okay. For some of you, it can be easier. So you write C++ code, then it's compiled to binary uploaded to the Arduino device, then Arduino compiles it a little bit again and places to the right memory chunks in Arduino itself. So it's actually a complex thing. With Espruino, you open the Chrome. I remind you, Chrome is the browser. And you click the button on a website, and it just connects to your microcontroller, and you just upload. You need no software. With Arduino, you need a whole bunch of things. Also, to debug on Arduino, you gotta be pro. So all of you, if you have never debugged in Arduino, you will not be able to debug on Arduino in a few hours. All right, let's move. Have I forgot anything? Yeah, another significant difference between Raspberry Pi and these two. On Raspberry Pi, you can do video conversion and attach display, all that like heavy stuff, Wi-Fi as well. These two cannot do battery and complex things because they don't have operating system. You know, it's only Raspberry Pi who have it. But Raspberry Pi, by default, you cannot read voltage from a pin. So you have a device, right? You have a pin. You attach a little wire, and you cannot read data from it on Raspberry Pi until you install some drivers, some whatever. And here, this is like a built-in thing. They all have pins. You just attach the pin, and you read the signal from that pin as a number. And since you have a JavaScript, you just attach a callback, and whenever there is a signal, you just receive a signal. It wouldn't be fair to not mention Vasyl. I'll quickly show you their website. Not this one, that one. Vasyl is a kind of a Raspberry Pi, but their language of choice is JavaScript, and they run Node.js. Why I'm showing you this? Because their website is awesome. Look, I'm moving my mouse, and it points somewhere, and that's the only way why I'm actually showing. And no, look at this. Boom. And boom. Yeah. They also manufacture additional devices like Arduino and Raspberry Pi that you can attach and measure whatever. But the power usage is similar to Raspberry Pi. You can write Rust, which is awesome on it, but mostly people are using JavaScript. And I also love these animations. And now the camera. You see camera? No camera? Camera. All right. So this is it. This is why I showed it to you. Of course, all of these 4 projects are open source, both hardware and software. Moving on. So Park.js and Pixel.js, other devices. There they are. And I don't know what else to say. Oh, they all are Bluetooth low energy powered. So when you debug or connect, you just connect through Bluetooth instead of a USB. You can connect through USB, but it's too hard. This is like children's exercise. You open the browser, go to espruino.com/IDE, and boom. Yeah, boom. I'm gonna demo right now how you connect to those devices. That's my. This is Pixel. This is Puck. I'm doing it with hope that this thing can focus. 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 Imagine it's focused. I'll click this button. Searching. Okay, I have only one Bluetooth controller on this device, and you see Pixel in the list and Puck. So I click Pixel, pair. It takes several seconds. It will be faster soon. And boom, now I'm connected to it. This is a JavaScript repo. Let's check what's the battery status. Get battery 99. Oh, that's a lot. It was 91 in the morning. I don't know. I don't know. Maybe it's not accurate. Oh, it's 100. Yeah, it is accurate. So that's your code on the right. You click it by you upload it by clicking this button. Also, there is a this button. You click it, and there is a visual kind of thing, drag and droppable. You can code by drag and dropping. Yeah, for kids probably. This code is not from what's actually uploaded right now on this device. It actually shows current temperature. So as you can imagine, the learning curve to debug and upload code is nearly 0. All we need to know is JavaScript. I imagine this a good alternative to teach your kids JavaScript or programming. Debugger. Debugger is the whole new thing. So this is an interactive debugger. If you will ever try to do interactive debugging in Arduino, it's literally impossible. Arduino is a black box. You just upload binary in there and then just hope. Let me show it. All right. I'm gonna grab a piece of code. Oh. That's a code. You see, I have a debugger statement here. I'm gonna upload it now. setWatch is a built-in function. It's actually a little helper function to subscribe to an event of a button. So you don't need to write some more code. This is just a shortcut. BTN means button 1. It's a shortcut for button 1. The Pux.js have 4 buttons. Sorry, not Pux, Pixel. It's Pixel.js. You probably heard that there's about 1 year ago there was a conference in Europe, and this thing was a badge for every attendee of this conference. And then they were able to program their own badge, and there were games on your badge, and you can actually communicate with other badges. So this was a really fun thing. I wasn't on this conference. So let me click this and see what happened. You see, I got into the debugger. It stopped. I hover my mouse over the count. It equals 1, as you can see. And it actually prints it over here. P count 1. Now you can see count.unexist. This line will throw, right? I want to show you how exceptions look. So run it. You see, these 5 buttons appeared. Let's run it. It threw. And it tells me the line and the column it threw it. You cannot have it in any other microcontroller. And also this thing takes 8 times less memory than Arduino. Sorry, not memory. Power than Arduino. Isn't it awesome? If you have ever programmed for a microcontroller, you would like jump right now and yell, "Whoa!" But yeah, it looks like only one of you did this before. Let me comment this function. Re-upload it. Click it. I'm in the debugger again. Run it. Click it. Mouse over. Have I clicked it? I haven't. I don't know what's going on. Oh, I forgot to run it. Run it. So mouse over, count equals. Oh, come on. Ah, the focus wasn't here. P count equals 3. So count equals 3 now. Tooltips broke. For some reason, I've never seen this before. Live demos, you know, they're hard. Let me comment out this debugger, re-upload it again. I will click a few more times. It should, you see console log, it should reach console log. I'm clicking and it's counting. Clicking, clicking. Now, fun thing, I'm not stopping the debugger, it's still running, right? In the REPL, I type the variable name, count, press enter, and it prints me the variable. So if you're measuring something with this device, at any point of time you can connect to it and just see the values, which is awesome feature by itself. All right. So yeah, cool thing, when it's crashing, you know where it's crashing. And I use this feature quite a few times because, well, debugging for microcontrollers is quite painful. This is a very popular microcontroller called ASP, whatever. It's a little Wi-Fi board, so it actually can do Wi-Fi. And you can upload, it's also a microcontroller, no operating system. You can upload any code there. And since Espruino is open source, you can actually upload Espruino on this device and have full Wi-Fi. However, it takes similar amount of battery as with Raspberry Pi 2, because Wi-Fi, you know, Wi-Fi is heavy on battery. Yeah, and you can run full TCP/IP stack. There are libraries for Espruino. You just basically can do Wi-Fi. You can have a web server running on it, kind of on Wi-Fi. You just need to plug it through this little micro USB port. Yeah, it costs from $2 to $10. Espruinos, I bought these for around roughly $50 each. Yeah, I wish I could buy more. I wish I bought more. You actually can do assembler or C. So this is how you do it in your code. Behind the scene, the IDE will grab this string, upload it to the Espruino API. It will compile it to binary, send the binary back to your IDE, and IDE will upload this binary to your device. Normally it can speed up your execution more than 100 times. So if you have some CPU heavy things, then yeah, you probably want to use this thing. But not all of the assembler and C is available, just subset of it. Fun thing, you actually can do this same with JavaScript. So if you don't know assembler or C, you can write a function, put the compiled over here, and this thing will be, again, sent to the server, compiled to binary, sent back to your IDE and uploaded to your device. But also, not the whole JavaScript, a subset of it is available. So some recent news. I read it a few days ago that Gordon created a firmware, the next version of it, which transfers data. When I click upload, for him, it transfers data 4 times faster. Fast initial connection, it can take up to 5 seconds. Now he claims that it takes 0.1 second. Yeah, and for some cases it will even drain less battery than the whole thing, because basically he's working on optimizing. Some non-technical facts is that, yeah, 3 successful Kickstarter campaigns, 50 releases of the firmware for Espruinos, yeah, done by himself. Open source, there is a community, people very active there, used all over the world, of course, even, believe me or not, in Australia. Special ports, you can grab this software and upload to a smartwatch or just watch without an operating system. I'm not sure what this magic is, but people say that they had a project like this and they succeeded. All right, we are coming to an end. This is almost like last slide. So, and now a bit of demos. Puck as a thermometer sends data to Pixel, which displays the temperature. That's the code I almost wrote. Actually, there is an example on the website. I modified it a little. Let me go through quickly. So you see set watch. If I click button 4, it will toggle the LED is the background on the pixel. It's just a background for your screen. Then every 6 seconds it scans for devices and looking which of them is advertising. So in Bluetooth Low Energy there is a feature called advertisement. It's more like broadcasting. So you're broadcasting some data, some bytes, and I'll be broadcasting temperature from one device to, well, and any other device. So it will find all the devices. You see some APIs, devices. I'll find the device I need by this number. I'll grab the numbers. There are 4 bytes I actually send. One of them, is it light? Let me show you how it works. I'm uploading the code now. All right. Focus. All right, some focus. All right, battery 100%. Whatever, it says battery 100%. Just need some distance.
Talk about it.
That'll do. So yeah, this one is advertising. And its first byte is either 0 or 1. If it's light around, it will say it's light. And if it's light, it will turn off the LED. If it's dark, it will turn on the LED. Let me cover this device with my palm and see what's happened. Maybe. There you go. And if I remove my palm, it should just go away. Yeah, there you go. Thank you for my terrible demo claps. There is another number it sends, is the battery level of my thermometer. What I did, I put this thermometer in every corner and every room in my house. Literally, I did it a week ago, and measured temperature there. In one room it can be 13, but same time in another room it can be 19 simultaneously. So I can already using this. This device is running on this battery for 1 week non-stop, and it's still 100% battery. It sends signals every 3 seconds. What else? What else? You can program every button. Click. You see? It's gonna turn off automatically right now. Oh my god. Focus. Last updated 6 seconds ago. You see? Yeah, I've added this feature. So that's the code. If I click button 4, oh, that's why it disappears. Not enough light. So, and I LED.toggle. That's the whole code for the button. And this is some drawing on the screen. There are 128 pixels and 60 from top to bottom. And yeah, some code to draw it, some code to scale the font up to 40 something and draw a string. Moving on. I'm using it as a temperature, right? There are light bulbs. The Puck.js, it has several sensors: infrared, temperature, light, clicky button, magnetometer, and Bluetooth. Yeah. So you can control with this button your light bulbs wirelessly through infrared or Bluetooth. It depends on your light bulb. If you have a programmable light bulb. 3 years ago, I had a customer and I lost the customer because what he wanted, somewhere underground, no internet, no power, but people walking by, it's probably a mine or something. People walk by, but they need to count, probably people. He didn't tell me what. So they needed a solution where people pass by, click something, and then it just counts people every direction. 3 years ago, Puck.js didn't exist. If it existed, I would use Puck.js. So every person would have a button, and they go towards their button and click it. And the button will stay powered for 4 years, because there will be only one event or 2 events per day. This is literally nothing for that kind of device. And then I would approach with my second device to those buttons and wirelessly read the data. But this is what I would recommend my customer back then if those devices would exist. It would, well, those little pucks would serve him for a year, 2, maybe 3. And the Puck.js, you can actually plug a micro USB to your Pixel. Yeah. And I wish, I helped my customer back then. I lost his contact now. Smart Bluetooth beacon. You know, there is a Bluetooth low energy beacons. There are a couple of competing standards from Google and Apple. There are actually a few more, but these are 2 major ones. They are kind of advertising, usually an URL. You can like go in a shopping mall, walk past a shop, and you will receive a notification. There will be actually an URL advertising to you. Hey, jump into my whatever Oogie stuff. Locate, yeah. So whenever you in these. These variables, they have actually RSSI. I don't know what this means, but SS signal strength. And you can triangulate and roughly understand the position of other Bluetooth device in a room by having 2 more devices. So basically 3 devices, all you need to locate 2 others. One of them, but you understand. What I'm thinking to do soon, so my Aircon, it's infrared through my remote. So what Puck.js can do, since I have an infrared reader and writer, emitter, you can take your Puck, write a little program which remembers infrared signals as an array of float numbers. You can point your remote control onto it, click it, Puck.js will remember this array, and then on button click, it can resend those bytes, float numbers, JavaScript array through infrared emitter and basically turn on or off my Aircon. This is what I'm planning to do soon. I would need a second Puck, so one Puck will be in one room, the other Puck will be in another room, and from one room I can click a button on one Puck, it will signal another Puck, say, hey, please turn on the Aircon. It will send this array through infrared and it will turn on the Aircon or off, whatever. Teach your kids to program. This is also a good application. I have some people who actually already told me they're thinking of buying it. And the last demo would be the longest. Bear with me, please. I'm going to connect to my Puck. When you connect to a device through Bluetooth, the advertisement stops. So, yeah, you can see that this number will not be updated in any time, in any near time. That's the code I'm gonna use. Take a look at this require. What it does underneath, when IDE compiles this code, it actually goes to a GitHub repo, grabs this file as a mini file JavaScript, uploads to the variable called controls, inserts, and then uploads the source code to the device. And this is how it kind of works, and it's a good thing. So this will advertise my Puck as a media controller, which can stop, play or pause, or skip to next. Take a look at the code. If time is more than 0.3 seconds, long press. then I'll skip to the next track. If it's short click, then I'll play or pause. And also it will blink a LED. Of course, I need to disconnect. Make sure it actually disconnected, because sometimes it's buggy. Now, on my device, you can see Park.js, click on it, done. Ready? Next track, long press, and it will blink. Take a look. You didn't see the blink, but it was red. You see green? No, you don't. You probably can see it like this. All right. This is it. Thank you.